Hi, this is Catherine Worley, and today we're going to be studying section 1.1 angles for trigonometry. All right, so let's talk about angles. Angles will consist of two rays. So a ray has a starting point and then goes off into, there's no end point. So we've got an L. There's a second ray. Where they meet is called the vertex, but it's also where we will put the name of the angle. So angles usually have uppercase letter names. So since my name is Catherine, I'm going to call this angle K. So we would say that this first side, which is usually associated with the x-axis, if this was on an xy plane, this is the initial side, and this is the terminal side. And when we measure angles, we go from the initial side up counterclockwise. So that would be considered a positive angle. Now, if you go in the negative direction, if you go in the clockwise direction, here's an angle. If we're measuring this internal measurement, that would be considered a negative angle. And we will talk about angle measurements in this section here. So this would be the positive angle measurement. Or if we went the other way, this measurement would be the negative angle measurement. Now we measure angle in units called degrees. And the degree symbol is that little circle superscripted. So in a circle, there are 360 degrees. 360 degrees implies a full circle. So we would say, for instance, this looks like this might be a 37-degree angle as it's measured. This would be maybe a negative 27-degree measurement. And angles are basically categorized by their angle size, by their angle measurement. An angle measurement is less than 90 degrees. That would be called acute. An angle measurement is exactly 90 degrees. We would usually mark that with a little box in the corner. That's the symbol to say a 90-degree angle. It comes to an exact square corner, like the corner of the page. That would be a 90-degree angle. We would call that a right angle. An angle that is larger than 90 degrees, but less than 180, we would call that an obtuse angle. And then an angle that has a vertex here that goes in exact opposite directions. This measurement here would be 180 degrees. That is called a straight angle. So acute angle, we would say the measure of the angle, measure of angle K, in that case would be less than 90 degrees. The measure of angle K would actually equal 90 degrees. The measure of angle K might be greater than 90 degrees, but at the same time less than 180 degrees. Here the measure of the angle actually equals 180 degrees. Now, two trig terms associated with angles are complements and supplements. So these words have other meanings in everyday vernacular, but in geometry and in trigonometry, the complement of an angle, or two angles that are complementary, or the complements to each other, when they are added, they will equal 90 degrees. Two angles that are supplementary, or two angles that are supplements of each other, when they are added, they will equal 180 degrees. So if you look on page 121, example 1 asks us to find the complement and the supplement. Find the complement and the supplement of a 40-degree angle. So if I have a 40-degree angle, the complement would be 90 degrees minus 40 degrees. The measure of the complementary angle would be 50 degrees. If we want the supplement of a 40-degree angle, that would be 180 degrees minus 40 degrees. That would be 140-degree angle. So that's example 1 on page 121. Okay, so we know that angle measurements right now are going to be in degrees. Let's look at example 2 on page 121. And here we have, they want us to find the measure of each marked angle. And you can see that this first angle is defined as 3x degrees, and this second angle is defined as 6x degrees, but then we see the little square box, meaning that together they are actually complements of each other. Together they add up to 90 degrees. So if this angle measurement is 3x, and this angle measurement is 6x, we know that 3x plus 6x has to equal 90 degrees. Combining our like terms, we get that 9x would equal 90 degrees. So x is going to be 10. So this first angle would be a 30-degree angle, and this second angle would be a 60-degree angle. Example B is actually a straight angle. And here we have the measurement. Here is 6x in degrees, and here is 4x in degrees. Now, since they make a straight angle, that would mean that 4x plus 6x would equal 180 degrees. So 4x plus 6x, combining like terms, we're going to get 10x is going to equal 180 degrees. Dividing both sides by 10, we get x is 18 degrees. So in this previous example, you would not circle x is 10 degrees. That's not the final answer. Here the answer was a 30-degree angle and a 60-degree angle. X was just used in the calculation of the degree measurement. Here my final answer is not 18. Here my answer is this angle is going to be 4 times 18 degrees. That's going to be 72 degrees. And this angle is going to be 6 times 18 degrees. That's going to be 108. So moving on to page 122. So far we've talked about degrees as measurements for angles, but degree is not the smallest measurement for an angle. There are 360 degrees in a full circle, but degree is not the smallest measurement. There are actually 60 minutes in 1 degree. We think of 60 minutes in an hour, which is true, but that's a different unit of measurement. There are 60 minutes in 1 degree. And there are also, you might be surprised by this, there are 60 seconds in 1 minute. And the notation, even on your calculator, you'll see the notation DNS. That stands for in the measurements, degrees, minutes, seconds. Degrees, minutes, seconds. So I might have an angle measure. Say measure of angle B is 37 degrees, 15 minutes. Minutes has a single tick as its symbol. 36 seconds. Seconds have 2 ticks as their symbol. So a degree has the little circle symbol, a minute has a single tick, and seconds have 2 ticks. Degrees, minutes, seconds. So this measure, this angle would be a little larger than a 37-degree angle, but it would be smaller than a 38-degree angle. So let's look at example 3. They want us to add 51 degrees, 29 minutes, and 32 degrees, 46 minutes. Now your calculator, your graphing calculator, which is a requirement for this class, can handle degree, minutes, seconds. So let me show you where that is. All right, so here we have our calculator, and here we have our angle button. So second apps is where all of your angle operations will be on this graphing calculator. So what was it? 51 degrees. So I'm going to put in, I'm going to type 51, and then I'm going to do second angle. And do you see the first operation is name of the degree? And then we had 29 seconds. 29. You're going to go to second angle, and your second option is the single tick. So that is 51 degrees, 29 minutes. I want to add to that 32 degrees, 32, second angle, and pick degrees. 32 degrees, 46 minutes. So I'm going to go to second angle, go down and pick my minute notation. And the calculator is going to come up with decimal degrees. So this is going to be 84.25 degrees. This is considered decimal degrees. As you can see, the answer is in decimal form. This is considered degrees, minutes, seconds. That notation, DMS, degrees, minutes, seconds. Since our question was given in degree, minutes, seconds, we want our answer to also be in degree, minutes, seconds. So the graphing calculator can convert the previous answer to degree, minutes, seconds. So with 84.25 over here as my result, that would be another angle operation. And we come down here and you see number 4 is convert. That's what the little arrow means. That means convert or save or change to degree, minutes, seconds. So the calculator is going to change that answer from decimal degrees to degree, minutes, seconds. So that would be 84 degrees, 15 minutes. And there are no seconds. If there are no seconds, you don't have to put the 0, but you can if you want. So we can do angle addition or angle subtraction. Example 3b says, what is 90 degrees minus 73 degrees, 12 minutes? So I'm going to come here to my calculator and I'm going to do 90 degrees, and then I'm just going to subtract 73 degrees, 12 minutes. And once again, my answer is given in decimal degrees, but I would like to convert that to degree minutes seconds. Right now, I could do second apps or go to my angle measure and pick convert to degree minutes second. Or since I already have that as an operation right up here, I can actually reduce my typing by going up to a previous operation and saying, yeah, I want to do that one again. And that would say that that is 16 degrees, 48 minutes. Degrees, 48 minutes. So example 4 says they want us to convert 74 degrees, 8 minutes, 14 seconds into decimal degrees. All right, so on our angle menu, we do have degrees and we do have minutes, but notice we don't have the two little ticks that stand for seconds. That's because we already have on our calculator here, we already have the double quotes, and that's what's going to stand for seconds. And it's the plus sign here. Alpha plus, you can see, are the two little ticks. Alpha plus are the double quotes, which is your seconds symbol. So, out here, let's clear up the screen. 74 degrees, 8 minutes, 14, and I'm going to pick the alpha key, alpha plus, and now I have the double tick. So 74 degrees, 8 minutes, 14 seconds is equal to 74.1372 decimal degrees. The calculator by default is in decimal degrees. If you ever want the calculator to give you degrees, minutes, seconds, you actually say, okay, convert to degree, minutes, seconds, and it would change it back, present it back to you in degree, minutes, seconds. All right, let's look at example 4B. Example 4B wanted us to convert 34.817 decimal degrees into degree, minutes, seconds. So that's going to be 34.817. Go ahead and make it a degree. 34.817 decimal degrees. And now we're going to go and pick our convert to degree, minutes, seconds. And that is 34 degrees, 49 minutes, 1.2. The calculator is pretty specific. We're going to round that down to 1 second. So when we're talking about representing angles on the page, we'll be talking about standard position. So if you have your standard Cartesian plane, which is your x-axis and your y-axis, standard position for an angle will always have the vertex at origin. Origin is 0, 0. And its initial side will always be along the x-axis. And its terminal side, typically we go counterclockwise. So that would be considered an angle in standard position. Now on the Cartesian plane, when we're talking about degree measurements, anything between 0 degrees and 90 degrees is considered in the first quadrant, Q1 quadrant. And these are always, it's one of the few places we use Roman numerals. in math. So this is considered the first quadrant. Between 90 and 180 degrees is the second quadrant. Remember, 180 degrees is a straight angle. 180 plus another 90 down here is going to be 270 degrees. And then a full circle would be back at 360. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, not 14th, the fourth quadrant. So angle measures always go positive counterclockwise, and the quadrants also go counterclockwise. First, second, third, fourth. As we get farther along in trigonometry, part of the description of the angle will tell you which quadrant the angle is found in. All right, so let's take a look at what an angle might look like in standard position. Okay, so let's say I have an angle here, and that angle measure is 55 degrees. It's in the first quadrant. Measure is 55 degrees. Another angle that is coterminal, meaning it has the exact same ray or position for its terminal side, would be, let me go ahead and take a different color here. Here's my initial side. And what if I go all the way around the circle once, that's 360, and up an additional 55? Those angles actually fall in the exact same place on the Cartesian plane. And it's just that for the second angle, I've gone around the circle one time. These are considered coterminal angles. So 360, one time around the circle, and then an additional 55. A 415 degree angle and a 55 degree angle are considered coterminal. They have the same initial side and they have the same terminal side. So let's go ahead and look on page 124, example 5. Here they want us to find the angle of least positive measure, which means the smallest positive number, that is coterminal, with a 908 degree angle. All right, well, let's see. Where would a 908 degree angle wind up? In which quadrant? Well, I'm going to, first of all, take the first time around the circle off that measurement. So 908 minus 360, that's going to leave 540. Sorry, 548. So one time around the circle, I'm taking up 360 of the degrees, and now I still want a 548 degree circle. So I can go around that circle again. So let's take out the second 360 degrees. That's going to leave 188 degrees. So not only did I go around one time, I went around a second time. That took up 720 of my angles. And now I have 188 degree angle. Okay, so here is 90. Here is 180. Here's 270. And here's 360. Here's my initial side, and my terminal side is going to be 8 degrees more than 108. So this angle is a 908 degree angle, and it is coterminal with a 188 degree angle. About the second example, we want a coterminal angle with a negative 75 degrees. All right, so with a negative angle, we go clockwise, not counterclockwise. All right, so we still have our initial side at 0, but now we're going to go down as our direction. So this would be negative 90 degrees. Going in this direction, that's negative 180 degrees. Going in this direction, that's negative 270 degrees. And then over here, negative 360. So negative 75 is about there. That is a negative 75 degree angle. But our question was, name the smallest positive angle that is coterminal. So that's this angle. It has that as its initial side, and it has that as its terminal side. So what is that measure? That's going to be 360 minus 75. 360 minus 75 is 285 degrees. So 285 degrees is coterminal with negative 75 degrees. And the last one is, what is the angle with the smallest positive number that is coterminal with negative 800 degrees? So what is coterminal with negative 800? As we know, negative angles go clockwise, so there's my initial point. So one time around, we're going to take off, we're going to go 360. So add 360 to see what's left. Negative 800. Pulling out the first 360, I still have 440 negative degrees. So that means I can go around the circle again. 360 more degrees. And I'm left with negative 80 degrees. This is negative 90. Negative 80 is about there. That is a negative 80 degree angle. That is a negative 440 degree angle. And that is also a negative 800 degree angle. But what is the smallest possible positive angle that is coterminal? That's an angle that has that as its initial side. And we're talking about that measurement. So that's going to be 360 one whole time around the angle, and we're going to take out 80 degrees, and we're left with 280 degrees. So a 280 degree angle is coterminal with a negative 800 degree angle. They have the same terminal location on the Cartesian plane.